Okay, this is a lecture on for Accounting 113. This is going to be for Chapter 5. The topic's going to be cost, volume, profit. And really, cost, volume, profit, it's really we're going to be studying using simple math, basically basic math and maybe some algebra, to look at relationships that companies look at. For instance, a company might say, should we raise or lower our costs? Well, sometimes when you raise your costs, that may sound to you that would be not intuitive. You'd say, well, let's not raise our costs. But sometimes you raise your cost to have a greater quality or to add a feature. Obviously, volume is an issue. What volume are you most profitable at? And volume can also deal with not just volume, but mix. Do we want to sell more or less of certain products? Profit is going to be, we're trying to maximize profit by really playing with these variables. By the way, playing with costs, well, there's literally hundreds of costs that go into any product, or certainly if not hundreds, tens of costs. So that's playing with all costs. And volume, there's an infinite number of volumes. And we're trying to come up with the best mix of cost and volume to maximize profit. But really the concepts that we're going to learn in this chapter are I think, pretty straightforward and intuitive, so I hope you like them. One of the things that we're going to do is, again, we're going to use these to try and maximize profit, to try and understand what service, what product we want to offer, to help maybe marketing and a company say, this is the best, market this product the most, it's our most profitable product. Don't market this one less, because we don't make hardly any money on that. We're also going to try and help managers understand how to control their costs and maybe how to make better decisions, even making better products just for a certain amount of cost. Anyway, to do this, we're going to use something called the contribution margin format. And contribution margin format, and it's a format of income statement. And it just looks like this. You take sales of any company, and you take less all variable expenses. By the way, this is the cover of your chapter you're supposed to read, and I'll post this. This chapter will be posted on Moodle so you can read it. It's about a 20-page chapter. I think it's pretty readable. But anyway, you take all the variable expenses out, and you get something that's called contribution margin. And then you take out, subtract out, again, minus all fixed expenses. And you get profit. Or net income, if you want to call it that. NI. Anyway, this is, again, you can see this is based on behavior, cost behavior. Sales, less all variable expenses, gives you contribution margin, less all fixed expenses, gives you profit. This is no different than any other income statement. In other words, you'll come up with the same net income as you learned in, I think it was, you probably learned how to do this in 1.1.12. Well, it's the same, you'll come up with the same net income, but we're just organizing it. In 1.1.12, you learned how to do it functionally. You'd say sales, less cost of goods sold, less selling, administrative, gives you net income. We're not going to do it that way. We're going to say sales less variable by behavior gives you contribution margin, then less fixed gives you profit. This is very useful for management because they really, most managers, once you get into a company for any length of time, you'll understand that we're putting like things together. These variable expenses behave like sales are constant per unit or relatively. Variable expenses per unit, contribution margin per unit. Fixed costs are always constant in total. So again, we're trying to segregate things in a way that gives understanding to it and lets us make decisions easier. And as we go through some of these examples, you'll see that it really does make things, your clarity of thought is increased by looking at things this way. By the way, the chapter does introduce this same concept in the form of an equation. If you just take this and turn it, this is again horizontal. And I guess let's keep it horizontal, or no, that's vertical actually. This is vertical. Let's change it horizontal. Let's take sales per unit minus variable expenses per unit minus fixed in total is equal to profit. Now again, your author introduces this and says you can solve many relationships. You can do a lot of analysis on CVP by using this equation. Do you see this is, again, this was vertical and I just turned it horizontal. There is one thing we need to add though. If we're going to do this per unit, which is much handier if you do it by units, you got to put in another variable called quantity. So again, let's put that in there times quantity. In other words, sales per unit times a given quantity, or I really wish I would use volume, but let's go ahead and say Q is this. V and Q are the same thing, quantity or volume. But take your sales times some quantity minus your variable expenses times the same quantity minus fixed in total, and you'll get your profit. We can use this equation, which is essentially this, to solve for many, I would say it'll always be a positive answer, but we can find out either the positive or negative effect of any kind of change in cost or change in volume or, anyway, there is one other equation, and I believe he does call this the equation method in your book. You do not have to know that. But he has another one that he calls, what's he call that second one? I think he calls that one, the formula. I remember, he does call it the formula. And you don't have to know that. You do have to know this, but you don't have to know the names of what we're using it for. And he says there's a shortcut where you can just say, well, it's a derivative of this equation right here. Break even is equal to fixed in total. That means fixed costs or expenses, fixed costs in total, divided by, again, take the sales price per unit minus the variable expense per unit, and you'll get break even. That stands for BREAKEVEN, and that's sales price. Sales price per unit minus variable expense per unit, divide that into your fixed costs and you'll get a break-even point. Now I know you're saying that doesn't seem like this equation, but I promise you I can take this equation and again rewrite it. All I'll do is put in, for profit I'll put in 0, and then I'll solve basically for a profit of 0, and if I solve for a profit of 0, I'll get this equation. You see the logic in that? If I rearrange this equation to solve for a profit of 0, this is what I'll get. Break even, which profit of 0 is break even. I'll get break even is equal to this. So these are all the same thing. This, and this, the equation method, the formula method, and simply the contribution margin format are all the same thing. They're just, this is taken and put in what? Vertical, this takes it to horizontal, puts it in an equation, and this is taking it and using a shortcut derivative from this equation to, and this really is probably what I'll use in class because it is easier, because it's organized in a way that's more applicable to what problems we're going to solve. But anyway, this is what we're going to apply, and we're going to apply it to a bunch of problems and see how we can do analysis to come up with, again, the best cost, the best volume to maximize profit in a multitude of different situations. Anyway, with that, let's go try and apply just what we've learned here. Let me pause it, and we'll come back after I erase. Okay, we're going to be working the first exercise in Chapter 5. It's called the foundational problem. It's on page 226. It's a foundational problem. That does mean it's a hard problem, and but it's a beautiful problem that it covers the entire chapter. It has 15 parts to it, which is quite a bit, and again, it really takes us through all the key concepts of the chapter. Anyway, let's take a look at this. The name of this company is called Oslo, again, O-S-L-O, and Oslo makes shirts. It says Oslo prepared the following contribution format income statement. That's what they've got. Remember, a contribution format income statement. It says based on a volume, again, based on a volume of what? 1,000 units. The relevant range of production is 500 and 1,500. That means sometimes they drop down to 500, sometimes they go up to 15, but they're right in the middle. That's their relevant range. Now again, it says they have sales. Now, try to remember, I wrote this stuff in my book, and I wish I had now, but anyway, this is what's really given. They tell you they think they're going to sell $20,000 in shirts. They think they're going to have variable expenses of 12. They're going to have a contribution margin of 8, and expenses of 6, and net operating income of 2. All right, that's great, but again, let's, one of the best things you can always do is try and get back to, again, volume. And what I mean is volume and per unit costs. For instance, we know that this is what? We know that they said this is for 1,000 shirts. So let's take 1,000 into 20,000, and we get $20. Do you see that? Again, 1,000 times 20 is equal to $20,000. We can do that with variable costs. Remember, variable costs stay constant per unit. All right, let's do the same thing with variable expenses. I really should have said variable costs and sales. We can do that. If you go to the gas station and buy $50 worth of gas, if you divide the gas by the gallons, you get the cost per gallon, do you see? So you can take the sales of your gas, divide it by the number of gallons, and get the cost per gallon. That's what we just did. $20,000 divided by 1,000 is 20 bucks. Same thing here. 12,000. If you take 12,000 divided by 1,000, you'll just get what? $12. $12 is what each shirt costs. That's the material, the buttons, that's the labor to make the shirt, sew it, that's the electricity for the sewing machine. Anyway, contribution margin, that's just the 20 minus 12 is 8, but we can still take the 8 and divide it by 1,000 if you want to. You don't have to, but 1,000 times 8. And then we're not going to do that with fixed expenses, because fixed expenses are fixed. Again, we don't want to get them on a per unit basis. If you remember again, that fixed expenses, we want to keep them in total. In fact, here's what we're going to do. For any of these problems, and in real life, it's nice if you say, well, I've got a total, but I'd like to get the information per unit. And I'd also like to get it on a percentage form. So let's again make a couple columns here. And say, all right, what do we mean by that? Well, per unit, we know each shirt does what? $20 is what it sells for. $12, do you remember that's the material and the labor of the shirt? Subtract those two and you get what? $8 in contribution margin. Now don't go ahead, and try and take the 6,000 and unitize it. You could divide by 1,000, but remember that's not going to be constant. Fixed costs don't stay constant per unit. Now let's go over here and do percentage. Out of 100%, when we bring in $1, how much of it goes to variable costs? Well, let's just divide, again, 12 into 20. Again, what percentage is 12 of 20? That's going to be, I think, 60%. Yeah, 60%. So we know that, again, 60 cents on the dollar immediately disappears and is gone, because that's what we have to spend to just get the shirt made. $12, again, 60% is really gone. We can even show it this way. That's 60%, that $12 is a negative. Then we result, what's, again, 8 into 20. Let's get a percentage there. 8 into 20 is going to be 40%. And that's going to give us 40%. So now we know that every time a dollar comes in, again, when I say 100%, I mean 100% of every dollar. When a dollar comes in, 60% of it, or 60 cents on the dollar, is gone immediately, but we're left with 40%. This is what we really want to focus on, do you see? This is the positive. When we sell a shirt, if you look at it, we really don't get 20, we get 8, because we lose 12. We really don't get 100% of a dollar, we get 40 cents on the dollar. Then what happens after we get $8? We use those 8s to pay off that 6,000. Once we get up to covering all of the fixed 1,000, then we'll make money. And that's exactly, again, this is the best way to always approach any kind of problem, and even in real life. If you're looking at any product and you're just trying to figure out, again, what's our, what kind of profit can we make on this, and again, what kind of volume do we want? Well, look, put it on per unit and put it on a percentage basis, especially if you have multiple products. If you have multiple products, you can see relationships right away as to which one has the highest contribution margin. Anyway, the first question says, let's see, 1. What is the contribution margin per unit? Oh, well, luckily we got that, don't we? That's pretty easy to get. What is the contribution margin per unit? It's 8. That's pretty easy to get. Contribution margin. If you want to put that in terms, it's what? Selling price minus variable expenses is equal to the contribution margin per unit. So the selling price is 20 in this case. The variable expenses are 12, and that equals 8. And that's our answer. All right. Let's do number 2. By the way, these are warm-up. What I mean is when we get deeper into this, I probably would not test you. I don't know if I test you on 1, 2, 3, or 4. But when we get into these, they'll get harder. And those are the ones I'll really put on the test. I think once you get up to 4, 5, 6, those are ones that I put on the test. These are just preliminary to get you thinking. 2, what is the contribution margin ratio? Well, we got that already too. The contribution margin ratio is 40%. We can go ahead and write that out and say, well, the contribution margin ratio is take the contribution margin and divide it by sales. And if we do that, the contribution margin in this case is $8 divided by 20, and that's going to be what we said, 40%. So there's our answer there. Okay, 2. Let's do 3. What is the variable expense ratio? Actually, we've done that too. The variable expense ratio, we've already got it. It's 60%. But let's go ahead and answer it again, variable expense. Well, just take your variable expenses and divide them by, same thing, sales. You see, again, it's natural in accounting to divide many things on an income statement by sales, because sales is the key number. Sales is what all other things are, everything's related to sales, and sales is your key number because it determines truly if you're successful or unsuccessful in a company. So sales, we're saying, hey, let's take our most important number and divide our expenses into it. If we do that, we're going to get, let me see, this was 12 divided by 20, which equaled, again, 60%. By the way, do you see that the contribution margin and the variable expenses add up to 100%? That's normal, and that'll always be the case. Let's see, what's 4? Now, we might be getting into test territory here. 4, if sales, okay, yes, this might be a good test. If sales increase from 1 to 1,001, remember, we're at 1,000. We're selling 1,000 units right now. That's where we're at. That's how this information was derived. And that actually, we could go back here and put 1,000. This information is 1,000 units, and we're making money, by the way. You see that? We are, again, making $2,000 in profit. Anyway, it says, if sales increase to 1,001, well, that's only 1 unit. What would be the increase in net operating income? They don't want the new net operating income. They didn't say the new. They said, what's the increase in operating income? Well, let's look at this. If this is the information for 1,000, well, if we go up by 1 more unit, we'll get 20. We'll spend 12 to make it, and we'll get 8. Now, you might say, what about the 6? We don't have to worry about the 6 because that doesn't change. What is the incremental amount of money we're going to get? The 8. So this will go to $2,008. Now, is the answer 2008 or is it 8? Let's go back. What's the increase in income? The increase is, as we just said, 8. So it would be, again, this one would just be $8. That's your increase in net income or profit. Okay, let's do 5. If sales decline to 900 units, if sales decline, now remember we're at 1,000, if sales decline to 900, what would be the net operating income? Now this time, remember a minute ago, they said what was the increase in income. This time they're actually asking what's the new net operating income. And they say if sales decline to 900 units, well, we're at 1,000. What happens if we go to 900? Okay, well we could recast the whole income statement. We could go back and let's say 900 times 20, and 900 times 12, and 900 times 8 minus 6 will give it. But can you see again that we can probably do a little bit of a shortcut here? We know that 900 is what? That's 100 less. So we can just say, well, on 5, If that's all they're going to change, you can say that's 100, and we can put a negative. We know it's going down. What do we lose with every shirt? We lose $8. Remember, that's your contribution margin. You know that again, you're going to lose, what you're really going to lose, you're going to lose 20 positive, 12 negative, but if you take that together, you're going to lose $8. So that's going to be, you're going to lose $800. Now, if they would have asked, what's the change, that would be right, but they didn't ask for the change. That's the change. They asked for the new net income. Well, take the old income, $2,000, minus 800, and that's going to be, and that's that negative. Whoops, I probably should have just, whatever, plus the 800. But anyway, that's $1,200. And let me just go and show you again. We're at $2,000 of net income. We just said, what if we go to 900? Well, again, that's 100 less times $8. That's $800 we lose. 800 from 2,000 is going to be the 1,200 that I just put up there. So, all right, what do we got? 6. What's number 6? Six, if the selling price increases by $2, by the way, these are all good for the test. I would say starting here and going on down, those are all testable. 1, 2, and 3 I probably wouldn't put on the test, but you have to know them. You see, again, to get the answer, you have to do 1, 2, and 3 to be able to solve the remainders. But if the selling price increases by $2, that means we're going to go up to what? $22 per unit, and the sales volume decreases by 100 units, I think this is going to say what? Cut this off. What would be the net operating income? So they want the new net operating income. All right, if again you want to, you can go back and recast this whole statement. You can say, I'll take, let me see, 900 times 22. Do you see it's going to be the $20, but you're going to raise the price by 2. 900 times 22, 900 times 12. Then 22 minus 12 is going to be $10. So 900 times 10, take out the fixed expenses, you'll get the answer. Let's go ahead and go over here to 6. And I'm going to do something like that. Let's just do this. We know we're going to go to 900, but we're going to take that times, let's again say, we know that again the new selling price will be 22. The old variable expenses are 12, so this is the new selling price minus the variable expenses. And that's going to be, what did I say, $10. So we know that, again, this is contribution margin. You see, I'm taking selling price minus variable. I'm just jumping to this because I want that contribution margin. So $10, that's 900 times 10. That's going to be $9,000 of contribution margin. You see, I didn't want to do sales and variable expenses. I just took the difference and said, I just took a shortcut here. Now, what do I take out now? I take out, after I get contribution margin, you take out fixed. Remember? Here comes fixed. Fixed is the same. They didn't say it would change. So fixed is still $6,000. And if you take that out, fixed or negative, that's $3,000 is your new income. And that's what they asked for, $3,000. Once again, do you see how you did take their change into account? If the selling price increased by 2, you see you got it right there, went from 20 to 22. But if the volume, they said, dropped by 100, you went from 1,000 to 900. You see, there's your two changes. This goes up by 2, this goes down to 900. Then times, again, that increment, $10, that gives you your contribution margin. A little bit of a shortcut, but not too much. But $3,000 is the new net income. Okay, let's see, we'll do 7 here. They ask us in 7. These are all good for the test. Very good. I like these. If the variable cost per unit, you see we're doing cost, let's again say the variable cost per unit increased by $1, because again, you're going to make the shirt out of a better cotton. Somebody says, if you make these out of a more expensive cotton, you will get more people to buy them. I know that, I don't know all the different kinds of cotton, but I know there's some that are clearly better than others. I know that because I've seen it in magazines where they'll say, if you want this kind of cotton, the shirt is more expensive. But if you want a more expensive, so they're going to go ahead and make their shirt out of a better cotton. Spending on, then they're going to have to advertise that. They're going to increase advertising by $1,500. Do you see their strategy? Better cotton, advertise better cotton, and they think sales will increase by $250. So again, this is a manipulation of what? Cost, volume, and they're asking us, what's the new profit? Oh, by the way, they're changing two costs. Variable cost is changing, fixed. Okay, I'm back online. All right, let me restate the question. They're saying if variable costs increase by $1, because we're going to put a better cotton in the shirt, and then we go out and spend $1,500 to advertise that we've got a better shirt, we think we're going to sell 250 shirts more. So do you see again, positive effect, 250 more, negative, spending $1,500, and again, negative here. So we've got really a positive change and two negative changes, and we're really trying to say that we think this is an overall good change. We've got costs going up, but we've also got volume going up. But I don't know, really, I really don't know in my mind if this is a good change. So let's go back and say, all right, they said we already had 1,000 that we're going to sell, but we're going to sell 250 more, so 1,250. Let's take that times, and again, the selling price is now still going to be $20, isn't it? $20 is the selling price, but minus 13. Again, remember we said the old cost of the shirt was 12, but it's now going to be 13 because we're going to add the better cotton. So this is going to be the new contribution margin, 20 minus 13, and that's again selling price minus variable cost. And that's going to be, I don't know to tell you the truth, let me see here, $7, I think it's going to be $8,750. Is that right? 7 times 7. Yeah, I think that's $8,750. So we will have sales of $8,750. Now, that's not sales, that's actually contribution margin. Now let's take out our fixed. We need to get the fixed expenses out. Again, I can write that right here, or I can put it just like I did fixed expenses. Now try to remember the fixed expenses were 6. But do you remember that they're going to add what? $1,500 in advertising? So we're going to go back and say, well, they were $6,000. That's the old fixed. But they're going to add $1,500 more. So that's going to give them $7,500 now in fixed costs. And those are negative. So that's going to be, is that going to be 1,075.85? I think that's 1,250. All right, and that's going to be your new net income. 1,250. That's bad, isn't it? Yeah, that's not a good idea, right? Because again, the net operating income was 2,000, so now we're going to 1,250, which that's not a good change. I guess really, let's go recap that. We increased our expense to cost to make the shirt. We increased our expenses to advertise the fact that the shirt is better, but that did give us an increase in volume. The increase in volume is positive. The increase in cost is a negative, and the increase in this fixed cost is negative. These two negatives are outweighing the positive. We simply would have to get more. We need to get what? If we're going to do this, we have to sell more shirts. Other than that, we really should go back to selling the old, we should sell 1,000 shirts. The 250 is not enough to overcome the cost increases. Okay, that's 7. This one, again, I'll test for sure. This one's number 8, and I'll ask this absolutely for sure to test. What is the break-even point in unit sales? What is the break-even point in unit sales? I'll always ask for that. Break-even is really quite a successful point. You might say, gosh, that doesn't impress me if somebody said they had a small business or a big business and they broke even. But you realize that if this college, again, breaks even, that's a wonderful thing. If this college breaks even, it makes enough money that it can pay everybody. Everybody gets all their salaries. They can pay off all the depreciation. They can pay for all the heat, light, utilities. That's a very successful year if you can break even. So break even is a beautiful number. Now, certainly we would rather make a profit, but break even means that you live to fight another day. Remember, 60-70% of small businesses do not succeed. they fail. So they never make it to break even. So that is a very important number. And you remember again, break even, this goes back to that original lecture, but in 8, break even, let's rewrite that formula. Break even is equal to fixed costs in total. And you remember we're going to take that and divide it by the selling price per unit minus the variable expenses per unit. And that will give us break even in units. This is again what they call the formula. I don't care if you know that, but they call this the formula method, but this is the one I would use if I was you. It's the easiest. And again, the fixed cost, let's just go get them. Here's the fixed cost. Here's the selling price. Here's the variable cost. That's everything we need. So we're going to take 6,000 divided by 20 minus 12, and we'll get that break even. Let's talk about the logic behind this. $6,000. And then we'll take, again, a $20 shirt price minus $12. And that's going to be $6,000 divided by 8. And that is going to be, I think it's going to be, let's see, break even, I think 750. Isn't it 750 units? Let me try that real quick. Sometimes it is 56. Yeah, that's right, 750 shirts. All right, do you see the logic in this, though? Without even looking at that, do you see all we're doing is saying, hey, every time we sell a shirt, we get 8. How many 8s does it take to cover 6,000? If you just take your contribution margin and divide it into that, this is a positive and this is a negative. Every time you get a positive 8, how many positive 8s do you need to cover $6,000 negative dollars? Well, in this case, you need what? 750 at 8s. 750 shirts will get you $6,000. You'll break even. And that is a very great number. Break even is very important. You can calculate the break even for this college. I've done it, and I think I know, or at least I've guessed pretty close to what break even is. And anyway, I think I think the break even is probably about 1,700 and some students. Anyway, let me break for just a second and erase this, or maybe I should just go over to the other side of the board. How about that? I'll just move over, I'll keep moving. Okay, I just left off with number 8, and we're with Oslo. I did shift this down so it might look a little bit different, and I had to rewrite this information because I shifted the whole problem down so we could see 9, 10, 11, 12, 13, 14, 15. But anyway, 9 says, what is the break-even point in dollar sales? Remember now, just a minute ago, it said, what is the break-even point in units? I know I'm stepping out of the screen, but it was 750 units. Well, I wish you could see that, but anyway, 750 units is what it was. So if we know that it's 750 units, we just calculated that in 8, 750 units times, that's break even in units. Let's just take it times how much it costs for a shirt, $20. So if it's $20 that we sell a shirt at, we know break even in dollars is what? 2 times 75? That's $15,000 in break even, and we'll call those are break even sales. In other words, you need 750 shirts to break even, or $15,000 in sales to break even. Either one, they're one and the same. One stated in terms of dollars and one stated in terms of volume. Okay, that I'd probably ask you to do that on a test. And let's see here, let's go back and do 10. 10 says, how many units? Here we are, 10. How many units must be sold to achieve a target profit of 5,000? Well, this time we want a target profit. We don't want to just break even. Well, we can use the same formula. Let's go back and take the formula that break even is equal to fixed costs, and I always just put fixed in total, divided by the selling price minus the variable expenses, and this is always per unit. And the only thing we need to do to change this, to go for a profit, is, you see the way this formula works, is in the denominator is the positives. In the numerator is the negatives. In other words, that's the money in a way, this is the money we spend. Well, if we want to change this formula ever so slightly, we can solve for, again, a desired profit level. Instead of calling it break even, let's just call it desired profit, and it's a volume that we're solving for. And it's the same equation. Let me just abbreviate. Fixed cost, but now we're going to put in plus the profit, divided by the same selling price minus variable expenses, and that's per unit. You see, again, we're still saying we make $8 a unit for a shirt. And again, we got to cover the fixed cost, but now we're putting in the numerator the profit. The equation doesn't discriminate the way it works. It just says I'll put 8 and find out how many times I need to take 8 and do whatever you want. We wanted break even, but now we want a profit. So let's go back and do that. Let's do desired profit volume is equal to the fixed costs, which, do you remember, they were $6,000. Now we want a profit of how much? $5,000. And take that and divide it by the selling price is 20 minus 12. So 20 minus 12, do that per unit, and you'll get $11,000. And let me see, that's 11 divided by 8. I don't know what this is going to be. Let me see here. I probably will have to take and calculate for that. 11 divided by 8. That's going to be 1,375 shirts. Something's wrong there. Can't be right. What was break even? Break even was, oh, do we have, oh, no, that does make sense. Break even was 750 units, so that is right. Yeah, 1,375 shirts. And that's shirts to profit being equal to, what was our profit? To $5,000. So there's your answer, 1,375 shirts. So what we have to increase, well, where are we at right now? It says remember when we started the problem, I said we're selling 1,000 shirts? Well, we would have to increase sales to make a profit of 5,000. We're going to have to increase sales to by 375 shirts. Okay, that's 10. Let's do 11. 11 says, what is the margin of safety? Well, we haven't defined that yet, but a margin of safety, this is very easy to understand because it is just what it says. The margin of safety is again, how much can you lose in sales before you're making nothing? And you may say, well, that doesn't sound too favorable, but it is favorable. How much can you still, making nothing is an achievement. Breaking even, that's what I'm really, making nothing and breaking even are the same thing. So they're saying, what is the margin of safety in dollars? And then they say, what is the margin of safety percentage? Well, let's just do margin again. Margin of safety is equal to current sales. And think about this, it makes sense, current sales minus break even. Now that should go into your head rather easily because you're saying, just take your current sales. Well, remember their current sales are $20,000? That's what they're selling right now. And we calculated what is their break-even sales. Well, their break-even sales are right here, $15,000. So you're really just saying, here's what I'm currently selling. Here's what I can drop down to when I break even. I can lose. In other words, I have $5,000 in sales that I can lose, and that's called my margin of safety. Okay, yeah. So margin of safety is equal to the current sales minus break-even sales, and there you have it, $5,000. So they're really saying we can drop by 5,000. Oh, they want that in a percentage too, I forgot. Remember, just take it as a percentage of sales. That's what we usually do. So part B of this, say to $5,000 is my margin of safety. Take that as a percentage of sales, which is 20,000. That's your sales. And that will be, I believe, 25%, isn't it? 25% is your margin of safety in percentage. 25% of that, what? Take 25% of $20,000 and you get $5,000. So your sales can drop by 25%. You can lose 25% of your sales and you'll still do what? Break even. Or you can just say $5,000 of my sales, either way. But that's margin of safety. I'll put that on the test for sure. I know that I'll put 9, 10, 11 on the test for sure, and going back, probably starting all the way with 4 to 15 will be on the test, I'm just sure. Different numbers and things. All right, that's 11. Let's see if I can squeeze 12 in here. What do they want in 12? Okay, this is a different concept, and I think it's a little bit, I think the degree of, it says, what is the degree of operating leverage? Well, the degree of operating leverage really is just a ratio. But like all ratios, you have to play with it and look at it a little bit to understand it. And let's just do this. Degree of operating leverage, I'm going to abbreviate that. Degree of operating leverage is equal to, we take the contribution margin, and we take the contribution margin in total, and then we divide it by the net income. And in this case, what does it really tell us? Well, I'll tell you in a second. Well, I'll tell you right now. Degree of operating leverage, it's again a measure of power, but it's also a measure of risk. Just like, again, I would say to you, if you have a really powerful engine in your car, I think the more powerful the engine, to get more power out of a car, your engine is at more risk of blowing up, and it really is. Anytime you ask for an engine or a lever or hydraulics or anything to carry a heavier load, they're at greater risk of failure, of breaking. Well, degree of operating leverage is like that. It really, the bigger this is, the better, but the riskier it is. So let's just go ahead and apply this. The degree of operating leverage here is the contribution margin total, that's $8,000. And let's take the net income 2. So our degree of operating leverage, our DOL, is equal to, that's 4. Now what does that mean? Well, this means that if, again, how much power does this company have? Well, in relation to the relationship between the net income and contribution margin, it means this. If there is, let's say again, a 10% increase in sales, 10% increase in sales, what kind of, what will our net income be? Well, this is the multiplier. If there's it shows the relationship between sales and net income. In other words, if we have a 10% increase in sales, take 4 times 10, we'll have a 40% increase in net income. Let's say that again. How can it be that if I have a 10% increase in sales, that I could have a 40% increase in net income? That really doesn't make sense. You would think that if you had a 10% increase in sales, that you would have a 10% increase in net income. But why is it that that's not true? Think about this. If sales goes up by 10%, it will cause variable expenses will go up by 10%. And contribution margin will go up by 10%. So why is it that net income won't go up by 10%? Because you know what happens to fixed costs? They don't change. So in other words, if you get a 10%, 10%, 10%, but then nothing, and this negative stays the same, then guess what? Your 10% increase will be multiplied into more net income. In other words, these will increase by 10%, but fixed costs won't, and therefore you get a bigger increase in net income. What is this relationship? Well, the degree of operating leverage tells you. In this case, it's 400 times, or not 400, but 4 times. If we have, a 1% increase in sales, we'll have a 4% increase in net income. And that's being caused because fixed costs aren't going up. Let's see, I think they asked us a fairly simple one in 13. And I think it just says, let's take a look at 13. Oops. Yeah, 13. Using the degree of operating leverage, same thing, I'll say, what is the estimated percent increase in net income if there's a 5% increase in sales? If sales go up 5%, sales will go up 5%, variable expenses go up 5%, contribution margin will go up 5%, but fixed costs won't go up at all. And that means that 5% is going to be much greater in net income. You're going to have a bigger than a 5% increase. What will that be? Well, your degree of operating leverage has told you. You can take the 4 times the 5%, and you will get an increase of 20% in net income. I don't really think it works out perfect if you put taxes back in. You know, we're looking at this without taxes, so it won't really come out that. It's pretty close to being right, but it's not perfect if you go back and put taxes into this. Okay, that's 13. Now, I told you a minute ago that degree of operating leverage, that you might just think, well, you know what, I just want that to be big. But I will tell you that usually degree of operating leverage, the bigger the number gets, you might say, well, that's appealing to me, but it's just like a powerful engine, and that yes, you know, you're going to get more of an increase in income, but there's risks that go with it, because the more the degree of operating leverage, not only if sales go up, you'll get a bigger increase, but guess what? If sales go down, you'll get a bigger loss. So like everything, it's just like an engine, there's more risk when you have that high horsepower. And degree of operating leverage, so you can think of this as not only a measure of, again, the effect to income, sales and income, but also a measure of risk. And that's what this next part of the problem addresses. It says, assume the amounts of the company's total variable expenses and total fixed expenses were reversed. We don't have to go any further and read the rest of it. That's what they want us to do. They want us to reverse them. Let's go up here and reverse them. They say, okay, take sales. Same thing, $20,000. Here's their proposal. Variable expenses will no longer be 12. It'll be 6. We're going to reverse them. They're going to take and we're going to invert these. Variable will be fixed and fixed will be variable. So the variable expenses now will be what? 6. Whoops, did I say that right? Yeah, 6,000. And now that'll give you a contribution margin of $14,000. And now if you take out the fixed, and the fixed are not going to be 6 anymore, they're going to be 12. You see, these are what I swapped out. And that's going to give us $2,000 of net income. Now you'd say, well, hey, Chuck, that's the same thing. But which of these do you think are riskier? If you had an engine, and that's really what a company is, it's an engine, and you want that engine to run, and you'd like it to produce what? You want it to produce a lot of income. It looks like this is the same engine, but it's not. It's been changed dramatically. This is an engine that has more horsepower. And you might say, why? Well, if you go from having $12,000 in variable expenses to 6, let me tell you what you've really done in life. Usually what variable expenses are, they're not as risky. Think about that. What's in variable expenses? Material and people. It takes material and men and women to put that shirt together. How are you going to really reduce that from 12 to 6? You're probably going to lay people off. And what are you going to replace people with? Well, you're going to replace them with fixed cost machines. And you say, well, that doesn't seem risky to me. But just think about a machine and think about a person. You can tell a person, I got to lay you off. Or can you take a furlough? Or can I cut your hours? But you can reduce a human being and say, take some time off. I can reduce you. But you can't take machines and again, under this situation, you can ask these people, could you go home for a day? Could I give you a furlough? Could I cut your hours a little bit? But the machines, you can't ask them to go home. You can ask them, but they won't move. You can talk to them all day, and machines won't do anything when you talk to them. Again, they'll just sit there. So again, you can't get rid of a machine. So these fixed costs are just what they say. They're sitting there, they won't go away. This is a much riskier scenario. This is, again, a higher horsepower machine. A machine will do great when you get to high volumes. You know, again, to make a machine worthwhile, you've got to stay at a high RPM, at high volumes. You've really got to produce. So if you are going to go and get rid of human beings and replace them with machines, you have to operate at a very high volume. That will work, but again, it's high risk. Because if you don't operate at a high volume, if you drop down to a low volume, you'll lose more money. Do you see? Let's just say you drop down to 0. Let's just take that scenario. If you drop down to nothing, here's what you'll lose in this scenario. If you drop down to nothing, you'll lose $6,000. You see, you won't have no sales, no variable costs, and no contribution margin. You lose 6. But if you drop down to nothing over here, you'll lose 12. Because again, those fixed costs, those machines won't go home. That's the nature of fixed costs. No matter what the volume is, you'll keep it. It'll stay there. So now looking at this, it does say, if we go ahead to this format, it asks, let's see, on 14 it says, what is the degree of operating leverage? So it's back to asking us the same as before. It says, what is the degree of operating leverage? Well, let's just take a look. The degree of operating leverage, you remember it again, it's going to be the contribution margin divided by, again, the net income. And in this case, the contribution margin, if you go back up there, what is it under the new one? It's 14,000 under the new high machinery. And the net income is 2. So it's a degree of operating leverage of 7. That's your DOL. DOL. DOL sounds like something on TV or something, doesn't it? Dead on arrival, dead on, I don't know what the L would be, dead on being late. Anyway, you got a degree of operating leverage of 7. That's better than 4. But remember, it's better than 4 because it's riskier than 4. 4, again, is more conservative. You know, again, the old method, you'll make, with this method, you won't make as much money when you're at high volume. You'll make more money at high volume, but again, you'll lose more money at low volumes. This one's high risk, high return. This one's low risk, lower return. Anyway, the last part, 15, just says, let's go back and do something that we did before. It basically says, go back and now assume that, again, the operating income, there's a 5% increase. You know, again, using the degree of operating leverage that you just computed, which is 7. What if there's an operating income of 5%, or excuse me, what if there's a 5% increase in sales? What happens to operating income? So if there's a 5% increase in sales, let's do that, 5%, another way, 5% times 7 is your degree of operating leverage. That's a 35% increase, and that's what they're after in income. Now, is 35% better than what we calculated before, which was 20%? Yes, it's better. But you can take that and flip it. If volume goes down, what you'll do is you'll lose 35% under this method, and you'll only lose 20%. So all this depends on what you consider your level of risk. If you're a small businessman or a small businesswoman, and you're deciding, again, do I want my company to have more people or more machines? Well, that depends on the level of risk you want to take, and it also depends on your confidence level. How confident are you that you'll have a high volume? If you can keep a high volume, then it's probably, I'd say it's better to go with the machines. Anyway, the foundational problem, we're done here. This is all 15 parts, and I will test this problem pretty heavily from about, as I said, probably 4 to 15. You'll see some form of those all in the test. And what I'll likely do, these will actually be in multiple choice. I'll more than likely give you a header, like you had before, a header, and then I'll take you through a series of multiple choice. And these will be, in other words, if I say if sales decline to 900 units, what would be the new operating income? Well, I'll give you 4 choices for that. Each one of these will have 4 choices, and you'll choose. Anyway, that's this one done. We're going to go next to Chapter 5, but we're going to go to exercise, I think it's exercise 16. I don't know what page it's on, but I'll get it ready to go, and then we'll do that. And then that'll be the end of this tape, I believe. All right. We're still in Chapter 5, and this time we're going to work exercise 516, page 231. And again, it's in Chapter 5, 516. I really like this problem because I think you can make it relate to college kids. I'll try to anyway. But anyway, this is more of CVP analysis. And in this situation, this says that they've got some place called the Hartford Symphony Guild, and they're planning to have an annual dinner dance. All right? The dinner dance committee has assembled the following costs. And actually, there's not just costs, but they're working on volume. I want you guys to think about this, though. If you can, just think about this maybe being what? Let's say, again, you're going to have a dinner dance for any kind of function. Let's say it's a charity, a sorority, a fraternity, the Spanish club, the Greek club, I don't know, the science club, the biology club, and you guys want to have a dinner dance. And again, your objective is not to make money. It's just, let's say your objective is really just to put on a dance for all your friends and break even. Or let's say it is to make money. Let's say you want to do it for charity. But either way, you can use CVP analysis to figure out how many people you need to get there to break even, and then how many people you might need to get to the dance to make some money. So either way, these are not concepts that are, again, lofty. You know, these are exactly the concepts you would be dealing with if you had a dinner dance. And these numbers are not far from being, I think they're a little bit too big, so they're a little bit, I think most college students might not be spending this kind of money on a band. But relatively speaking, you could scale these numbers back and you could have, again, a dinner dance here in town with your favorite band, perhaps. Anyway, they go on to say that, first of all, that down here it says they are going to price this at $35, meaning $35 a dinner. So let's just write that up here. They think they can get $35. That's, again, the cost to each person. And that's not bad. They think, well, that's nice. And then here's their summary. They think the cost per dinner is $18. Now that, again, let's say that some catering services, I'll give you a choice of chicken or a beef or a fish dinner, any of three, and I can provide it for $18. And then favors and program. Let's again say that each person that comes gets a nice little program that says all the songs that are going to be played. And also you get a bag of Hershey Kisses. And the Hershey Kisses are all labeled again for that event. Let's again say it is the Hartford Symphony Guild, and it has the date on it. And then the band, let's say the band, it costs $2,800. Now that is a pretty expensive band. Again, it sounds like a symphony here, but let's say you guys get a band. Let's say you guys got hired the band Jet. So you guys go get the band Jet, and you just want to have a dinner dance for, let's say, the biology club. And the rental of the ballroom, that costs $900. And again, professional entertainment during intermission. Let's again say that is going to be a ventriloquist. I don't know. You're going to get a ventriloquist in the intermission for $1,000. And then tickets and advertising are going to be $1,300. All right, the first question is, that I think all of you might have in mind is, what's the break even? What I mean is, how many people, with all this, how many people do we need to come to the dance just to have the dance? No more, just to have the dance. And we can go back and say, well, we know that, again, going back, that break even is equal to fixed costs in total divided by the selling price per unit minus the variable expenses per unit, and that will get you break even. All right, well, let's go back and do that. Let's drop down here and do break even. All right, when you look at this, what do you think are fixed costs? Remember fixed costs. Now, what kind of volume are we talking? When you're talking about a dinner dance, the volume is the number of people. And again, if 1 or 2 or 3 or 4 or 5 or 6 people come, what are you going to have to pay for the band Jet? Well, you've already signed a contract. It's $28. Doesn't matter. What kind of costs, again, stay the same regardless of volume? Well, I'll tell you what they are, fixed. That's a fixed cost because it doesn't matter how many people come, you got to pay Jet $28. No matter how many people come, 1 or 10, you got to pay for the rental of the ballroom. No matter how many people come, you're going to have to pay, I can't remember what I said that was going to be. Ventriloquist. Ventriloquist is going to stand up there if there's no people there, and he's going to give his act, or her act. And tickets and advertising, you'll have already spent this money by the time you even get to the dinner dance. These are all fixed. Can you see that? And these are variable. If nobody comes, you're not going to buy any food. If you go out and you never sell any tickets, you're going to tell the caterer, don't give us any food, and don't give us any favors. So these are fixed, so let's go ahead and put those fixed costs in total in the numerator. Those are going to be what, $2,800? Is that what the first one is? $2,800 for the band. The rental of the ballroom is $900. The rental of the ballroom, then the professional entertainment is $1,000. And let me see, professional and tickets and advertising for $1,300. And then we're going to divide this by the selling price. $35 is a ticket. And what are the variable costs per unit? Well, let's go back. It's going to be $18 for the dinner plus $2 for the favor. And this comes out to be $6,000. So you got $6,000 in the numerator, and 35 minus 20 is going to be 15, isn't it? Yeah, $15. And once again, do you see how the contribution margin is, this is again the contribution margin. 35 minus all variable costs, that's contribution margin. Well, all we're asking is, if you got, every time somebody comes to the dance, you see you don't get $35. When they come to the dance, immediately $20 of that disappears. So every time somebody comes to the dance, you get 35 minus 20, you get 15. How many 15s do you need to cover all those costs? Well, in this case, 15 into that, that's going to be 400 people, isn't it? So our answer is 400 people to break even. And that's an important number. That's really all your goal is. You're just saying, I really want to have this dinner dance, and I just need 400 people there. Well, I'm going to guess, let's say you're at Illinois Wesleyan, that is a pretty good amount of people, especially now that we got the coronavirus. I'll tell you how many people you're going to get there. 4. Maybe not even 4. So you got a real problem. Anyway, let's say this happens after this coronavirus thing blows over. I really do mean blows over. But let's again say you look at this and you say, you know what, I still don't think we can get 400 people there. And somebody says, well, why? And they say, well, I'll tell you why. Last year only 300 people came. And you say, that is pretty, I guess that's information that is, sobering. You're basically saying, I think that's, we're being optimistic. I don't think we can get 400 people there. Best we can do is 300 based on last year. Attending the dinner dance. If the same number attend this year, what price per ticket must be charged in order to break even? So they're asking the same question. Break even. They're saying that 300 people will attend, but they are asking what price per ticket must be charged. All right. Really what's going on here is they're telling you we have to break even with 300 people. They're going back and saying, this number that you got right here, it has to come out 300. That's all we're going to get. So let's just put that into the equation here. In number 2, we know that, again, if you take all these fixed costs, and by the way, let's just cut to the short of here. We know there's $6,000 in fixed costs. $6,000 in fixed costs. We know that, again, we don't know, actually. We don't know what we're going to charge. The selling price, we do know the variable expenses are still going to be 20. You with me on that? Selling price, the variable expenses will be 20. But they're saying to you, what price per ticket? You see, that's what they're doing. And we already know that this has got to equal what? 300. In this case, can we solve? Again, we know that, again, the fixed costs, they're going to keep the same band, the same favors, the same professional entertainment. This is all going to stay the same. The same cost, the same party favors, and the same cost for a dinner. This time, we have to know that, again, we're only going to get 300 people. What they're asking is, if volume goes down, you see, if volume goes down, what do you think is going to happen to selling price? Selling price has got to go up. Let's solve for that, and that's what they're asking us to do. They say, what price per ticket must be charged? Well, in this case, let's just cross-multiply. Again, cross-multiply and get this. Let me see, 6,000 times 1 is 6,000. And again, 300 times SP, that's 300 SP times the selling price. 300 times a negative 20 is negative 6,000. All right, and we're solving for what's selling price. All right, let's isolate SP. Let's add a negative 6 to each side. Really, let's add a positive 6 to each side. So again, we'll get 12,000 over here. Well, a positive 6 to this will leave it, it'll get rid of it. And we'll have 300 SP. Now let's isolate the SP by doing what? We can multiply by each side, or just divide the whole thing by 300, but multiply by the reciprocal, or divide by it, whatever. But anyway, in this case, we're going to get SP is equal to 1,200 divided by 300, or 12,000 divided by 3. 3 times 4, that's $40. That's what it'll come out to be. 12,000 divided by 300 is $40. The selling price has to be $40. So, if we only think that 300 people are going to come, now we know the volume, we know all the costs, we know all the fixed costs, we know the variable costs. What price do we have to charge? And this is again, very applicable. Cost, volume, profit can be applied to almost any situation where if you guys said, I want to have a chili dinner, and I want to have 50 people come to my chili, let's say it's a chili dinner for again, a charity. Well, again, you can use exactly the same concepts to figure out what do you need to break even. That's the first thing, is you don't want to lose money on the chili dinner. And then how many people would you, if you want to get a profit, and it's not a profit, whatever your profit is, you're going to give away to the charity. But you can put that in there too. Remember, if you want a profit, just add it to the numerator, and you can figure out how many people you need. All right, I'm going to test you on this for sure, on the test. I'll test you on 2. And then let's go ahead and I just want to put one last thought in your mind. If we were really doing this, do you see how easy it would be for you in real life to say, hey, we can't get 400 people there. Why don't we go ahead and try and get, because we're Illinois Wesleyan students, why don't we try and get the $900? Maybe there's a facility on campus that let us use free. And that $1,000 for the ventriloquist, let's just again not hire that guy or girl. And let's go ahead and see if we can get the marketing down. Maybe we can again get people to do stuff for free with their computers and social media. And let's keep the band jet. That's our key component. So do you see how you could play with these and really try and get down to maybe 200 or 150 people? By again, once you get the costs in this format, you can really work with it and say, what's a solution that will work in the environment I'm in? That's the whole point of cost, value, profit, is trying to make the best decisions with the real situation you're in. Anyway, going to 3, refer to the original data, $35 ticket price per person. Prepare a CVP graph for the dinner, dance, from 0 tickets to 600 tickets sold. I will pick that up in the very next video. I'll finish that part 3 in the next video, and I'll finish the chapter. I believe that the chapter, we have to do one more problem. It's problem, what was it? I think it's 522, I think. I'm not positive, but I think 522 finishes the chapter. But I'll do part 3, because that part 3 is a little bit longer, and then I'll do 522 and finish the chapter in the next video. Anyway, have a nice day.